Hi, how are you? I'm happy to be with you today. This is the second video for me on YouTube, okay? In this video, you are going to identify the exponential function, graph, and different transformations. So by the end of this session, inshallah, you are going to identify the different transformations having to this function. Either we have translation in x-axis or y-axis, or reflection in x-axis or y-axis, or the asymptote line, or stretching. Okay, also if you are given the curve of an exponential function, how to find its equations. These are what you are going to do now. Let's start by showing our slides. I'm going to share with you the first slideshow, the exponential function, graph, and transformations. So these are the objectives we are going to cover for today. General forms of the exponential function, different transformations on the exponential function, deducing the function in if given the graph. So let's start. As we said before, the exponential function is in its basic form is f of x equals b to the power x, okay, where b belongs to r positive difference 1. Also, we have more general formula for the exponential function, which is f of x equals ab to the power x minus h plus c. And we have here from the definition of the exponential function that a is any number belong to r, and b belongs to r positive difference 1, and x belongs to r plus c, any number belongs to r. Then this is the general form of the exponential function, okay? Then we have two different techniques here. If the base b is greater than 1, and if the base b is included between 0 and 1. If the base b greater than 1, then we have number greater than decimal fraction. We have a number. We have a number greater than 1. Then if you raise this number to any power, then the more you put numbers here greater and greater, the more you get f of x greater and greater. So the curve of this function goes bigger the more you go toward this direction of x-axis, okay? And here we have a curve like this. It is increasing curve on its domain, which is r, and this curve intersects y-axis at the point 0 and 1. How did you get this point? If you put down here 0 instead of x, then 2 to the power 0, which is equal to 1. Then the intersection point of the curve with y-axis is this point 0 and 1. And the more you get closer to negative infinity, x gets closer to negative infinity, the more and the more f of x gets closer to 0. And this curve approaches to the x-axis, but does not touch it and does not intersect it, okay? And we say that this line, this straight line, which is x-axis, is called the asymptote line. It is a line to which the curve of the function approaches, but does not touch or intersect, okay? So this function is increasing on its domain, and the range of this function starts from 0 to positive infinity. We look at y-axis. Also in this graph, f of x or g of x here equals half to the power x. Then the base here, which is half here is included between 0 and 1. Then in this case, we have a decay. This case is called growth function, and this case is called decay function. In this case, the curve of the function is decreasing on the domain of the function, and the domain here is the same as this one, is r. And the intersection point of the curve with y-axis is also 0 and 1. If you put down here 0 instead of x, then half to the power 0, which is 1. This is the intersection point, okay? And the domain also is 0 to infinity. And the more you get closer to infinity, f of x gets closer to 0, okay? Then there is a contrast or contradiction between increasing in x and increasing in f of x. Let's complete our discussion. If we try to draw the two functions in one, we will study that before. Let's talk about the different transformations. Shifting in x, okay? What was the shift in x? Shift means translation in the positive direction of x-axis or the negative direction of x-axis according to the number put here, okay? The number put here. If this number is this is 3 to the power x is increasing function or growth function. As you see, the intersection is 0 and 1 with y-axis. And here, if I subtracted 1 or 2 or 3 or added 1 or 2 or 3 for the index or the power here, then we have a shift. And this shift is opposite to the number here. If this is -1, then we have a shift in the positive direction of x-axis and its magnitude is 1 unit, okay? And if we try to draw the two curves in one graph, then this is the main or basic one, 3 to the power x, and this is the shifted one, is 3 to the power x minus 1. And if you note that the intersection point of this curve with y-axis is 0 and 1, then the image of the point is 0 and 1 by the translation 1 unit in the opposite direction of x-axis, it will be 1 and 1 as you see here. Okay, let's complete our discussion. Shift in y-axis. Shift in y-axis, if I added 2, I did 3 to the power x. Okay, this absolute term here is making a difference here. It is making a difference between the two functions. It makes the function gets above 2, and here we have this line, which is a asymptote line. Okay, then we have shift in the positive direction of y-axis, its magnitude is 2 in this direction. Okay, then they have the same domain, but the range here is different. The range here starts from 0 to infinity, and the range here starts from 2 to infinity. This is called the asymptote line, which its equation is y equals 2. If we try to draw the two functions in one graph like this, then this is the basic one, the orange one, and the blue one is the shifted one toward this y-axis 2 units in the positive direction. Reflection. What about the reflection? We have two different types of reflection. Either we have reflection in x-axis or reflection in y-axis. Let's start first by the reflection in y-axis. Reflection in y-axis means if you change the sign opposite to the power x to make it 2 to the power -x, and you can disjoin or separate this two powers by making this technique 2 to the power -1, which is equal to half, all to the power x, and half is a number included between 0 and 1. So this curve is a decay like this. And if we try to, and this point, the intersection point will also be 0 and 1. And if we try to draw the two functions in one graph like this, then they meet on intersect at one point, which is 0 and 1, and y-axis is called the axis of symmetry of the two functions, both two functions together. Okay, these are the two functions in one graph. Then if you change the sign of x of the power here, then you make a reflection in y-axis. Let's talk about the reflection in x-axis. If you change it, the index or the number opposite to the base like this, it is 2 to the power x. Here g2 equals -2 to the power x. Then if you change it, the sign opposite to the base, then you make a reflection in x-axis or the asymptote line, as according to the given example. Okay, then this is the reflection here. This distance between 0 and 1 is the same as the distance between 0 and -1, and you can make a reflection in x-axis. If you assume this is your mirror, when you're standing in front of the mirror, then you see yourself. In this technique you use, if you're standing in front of the mirror, we will use here to make a reflection in the x-axis. If we try to draw the two functions in one graph like this, this is 2 to the power x, and this is -2 to the power x, then changing the sign opposite to the base, making a reflection in the asymptote line, and this distance is the same as this distance, and the distance between any point here and the x-axis is the same as this distance and this curve. Okay. What about reflection is followed by another reflection? If I change the two signs, pose two signs, this sign and this sign as this, then what will happen? In this case, we have two reflections, reflection in x-axis and reflection in y-axis. I'm going to share another program with you to make sure that you will get the idea 2 to the power x and 2 to the power negative x. If I'm going to try to draw 2 to the power x plus 3. Okay, how to draw this function? If I try to draw this function, then this function has a translation 3 units in the opposite direction, in the positive direction of y-axis. Then I'm going to try to f of x equals 2 to the power x plus 3. Then this is the curve. Here we have a curve. Okay, this is the curve of the function, and the asymptote line here is y equal 3. And if I'm going to try to make two shifts, I am going to change the sign here and the sign opposite to here. If I'm going to try to do this, then the other function will be g of x is equal to negative 2 to the power negative x plus 3. Then we have another shift. Then we have two shifts here. Shift in x-axis and shift in y-axis. If I try to draw through y equals 3, then this line, as you see the black one here, is called the asymptote line of this function and of this function. Then we have a reflection, 1 in, if you change this sign, then 1 in x-axis, then is followed by 1 in y-axis. Then you will, if you try to find out the relation between this curve and this curve, you will find out that this curve is the same as this curve by reflection in this point, the one to which the asymptote line path, or through which the asymptote line pass. Okay, this is the meaning of changing the two signs, negative 2 to the power negative x plus 3 and 2 to the power x plus 3. This is the difference between them. Then we have a reflection in the point through which the asymptote line passes. Okay, let's move into or turn to our slides. Okay, then this is our graph. Okay, and this is the asymptote line, and these are the changes having to this curve. They have this curve is the same as this curve, but by reflection in this point. In this example, if you are given a curve like this, and he told you that this curve represents a curve of an exponential function, try to find an equation for this curve. First of all, you must know that the formula used to find this curve is f of x equals a b to the power x plus c. First of all, you have to determine the asymptote line, which represents c. Then c represents the asymptote line, which is 3. Then c here equals 3. The line to which the curve of the function approaches but does not intersect is y equals 3. Therefore, c equals 3. Then we have to, if I try to rewrite the equation again, then we have f of x equals a b to the power x plus 3. Then we have two different variables, and we have to find them. How to find them? Then check any 2 points to make it easy, but not any 2 points. It's points which makes your computations easy and easily to do them. Okay, then if I checked the point 0 and 4 and point 1 and 7, and I started to plug these values into the given equation, then what will happen? Let's start first by the point 0 and 4. Then plugging 4 instead of f of x and 0 instead of x, then we will get the value of a as b to the power 0 equals 1, then a equals 4 minus 3, which is equal to 1. Then we write down the function, then f of x equals b to the power x plus 3. Again, do the same technique by plugging the value 1 and 7 here. Then 7 is equal to b to the power 1 plus 3, and you can deduce the value of b, which is equal to 4. And in general, you have the function f of x equals 4 to the power x plus 3. Okay, then if you are given a curve and he told you that this curve represents a curve over an distribution function, then you have to do 3 things. The first item, you have to make sure that you can find perfectly 2 points to make not any 2 points, but the 2 points make your computations more easily and easier than usual. Okay, number 2, you have to find out the asymptote line. The asymptote line which represents C, the equation with the asymptote line which represents C. Then plugging these values into the equation, you can find the equation of the exponential function. What about stretching? Stretching means maximizing or minimizing the number of the 3 to the power x. If this number go bigger and bigger, if you note that this curve is 3 to the power x and this curve is 2 times 3 to the power x, then we have here stretching. When you maximize the number opposite to the base and maximize it more and more, the curve gets closer and closer and rapidly to f of x more than the other. Okay, this means, in other words, you can say that the amplitude of the curve gets closer and closer to f of x, and the f of x gets closer. If you plug in the value 0 and 1 here, this number lies on this curve, and in the same time the corresponding number on the other curve is 0 and 2. Then 2 precedes 1, okay, by 1 part. Then the curve for 1 point here, the curve has a value 2, and for the same point the curve has a point 1. Then f of x here is greater than f of x here, and the more you make this number bigger and bigger, the more the curve gets closer and closer of y-axis, and the corresponding values of x here gets bigger and bigger more than the other. Okay, this is the meaning of stretching the curve. Okay, and this is exercise you can do as an assignment for your home, as homework in your homes. Okay, and this is the other exercise. Okay, find out the equation of the given function, and until I'm finished now, until the next time, see you. Bye bye.